Hey everybody, welcome back. Mr. Smith here. In the real world, forces very often come in combinations. It's hard to get rid of wind resistance, so wind resistance is very often around. It's really hard to get rid of friction, so friction is almost always around. And what I'm going to do is to show you how if you can handle two forces acting on an object at the same time, you can handle any kind of situation, no matter how complicated it is. So here's a real life complicated situation. They've put a Porsche 911 into a wind tunnel, and streams of air represented by smoke are being generated that flow in columns. So this is a really cool situation where they flow wind at high speed in these narrow bands over the top of the car, and designers can look at the way that the air interacts with the car. So you don't have to be a genius though to figure out if wind is smacking the front of the car, it's going to tend to exert a force on the car that pushes it back this way, and that's wind resistance. Also, if you think about it, some of the wind, because it's hitting the windshield at an angle, may tend to push the car down, and that's not a bad thing. In fact, car manufacturers of high-speed cars design a wing in the back to do exactly that, to push the car down, because in most of these cars, the engine is in the front of the car tends to be heavy, and you want both tires to have the same amount of downward force onto the road. Anyway, that's a lot, right? You don't need all that. What we're going to do is to give you a simple kind of cartoon example and a few rules to show you how you can deal with any of these situations. So to begin with, whenever I have forces that are acting two or more at a time, I always draw a thing called a free body diagram. So you could take a piece of clip art from the internet like I did and use that for your free body diagram, or you can draw a blob. But if I wanted a force to act to the right on this car, I would just draw an arrow like that. That's it. So what I'm going to do, secondly, is to pick directions and stick with them. What that means is that if I draw a force to the right, in my head, I'm always going to call that the positive direction. If I have a force that acts up on the car, I'm always going to call that the positive direction. So that means that down and to the left are always negative. You'll see that becomes a big deal when we get to the math. Third thing, what does the math look like? Newton's second law says that the net force equals m times a. So we've already talked about that. Also, Newton's second law is what you get when you add up all the forces. So F net equals the sum of all the forces, as long as you've called some of them plus and some of them minus. So I'm going to step you through that and show you actually how easy it is to tackle these problems that involve multiple forces. So to do that, we've got a few kettlebells, and we're just going to walk through 5 or 6 examples of kettlebells with different forces and different combinations of mass and stuff. So first one first, we've got force to the left of 5 newtons acting on this. So what do I draw? Just draw an arrow, and I'm going to call it minus 5 newtons. So I told you I was going to do that. There it is. Force to the right is equal to 7 newtons. I'm going to try to draw that arrow a little bit bigger. It helps me when I get down the road. You'll see why. So anyway, I've got my force diagram done. Now I'm going to go on and do Newton's second law, which says if I add up all the forces, so 7 newtons plus a negative 5 newtons equals m, we'll just pencil it in, equals 1 kilogram times A. Do the math, I get positive 2 newtons equals 1 kilogram times A, and that's supposed to say 1 kilogram over there, sorry about my K. And anyway, you get acceleration equals 2 meters per second squared. It came out to be a positive 2, right? So if you're paying attention, you'll recognize that that positive 2 means that the object is accelerating to the right. So A is this way, over here. Okay? Let's do the other one. Force going to the left is 40 newtons. Okay, so I'll put in an arrow over here, call it minus 40 newtons. Force going to the right equals 30. It's not quite as big. M equals 10 kilograms. Just go ahead and do the steps. Add up all the forces equals m times a. So minus 40 newtons plus 30 equals m, so 10 kilograms, times my a. Do the math over here, and I get minus 10 newtons equals 10 kilograms times a. And then that means that a turns out to equal, this time, negative 1, right? Meters per second per second. What does that really mean? Notice there was a tug of war. We had 40 newtons going to the left, 30 newtons going to the right. oh, acceleration came out to the left because it had a minus sign on it. So that's why it's important to stick with your pluses and minuses. By the way, that doesn't mean that the kettlebell is necessarily moving to the left. That would be velocity, right? So if the kettlebell were at rest, an acceleration of -1 meter per second will make it move to the left. So at rest will then be moving. And if an object was moving to the left and it had an acceleration of -1 meter per second squared, it's going to accelerate. It's going to get faster as it goes to the left. But what if it was moving to the right? Well, it's just going to slow down. Okay? So hopefully that's all a good review right there, all in one easy package. Next example, force to the left is 10 newtons. There we go. We know what to do. -10 newtons going over here. Force to the right. Oh, this time it's a mystery number. Let's call it x. I wonder what's going to happen. This time they give us the mass and they give us the acceleration. We can deal with that. -10 newtons plus x equals 5 kgs. And here's why it's really important to be consistent. I see an imaginary plus sign in front of that 2 meters per second squared, and I just made it explicit. So I have -10 newtons plus x equals kilograms times meters per second is what a newton is. So this equals 10 newtons over here. Do the math and you get x equals 20 newtons. Okay? Fair enough. Let's see about it. Yeah, that's right. The acceleration was to the right. So the winner of 20 versus 10 had to be on the right side. Fair enough? All right, let's keep going. Force left equals 100 newtons. -100 newtons. Force to the right is a mystery. Okay, we've done that already. There's my x. Mass equals 10 kilograms. Velocity equals 20 meters per second steady. Wait a second. Isn't that a misconception that people confuse acceleration and motion? Oh yeah, steady velocity is motion, right? That means the acceleration of this thing equals 0. Oh, is that going to work its way into my math? You better believe it. Check it out. If we do the math, we're going to say -100 newtons plus x equals 10 kilograms times the acceleration, nothing. And so what happens is this whole side goes away, right? What does it really mean? Is that if -100 newtons plus x equals 0, that means that x equals +100 newtons. And this is the essence of driving at steady speed. When you were a new driver, you had to figure out how much gas do I give the car at this speed so that it doesn't speed up and it doesn't slow down. Because wind resistance and friction are pulling back against the car, and you had to figure out a way to just make those equal. So how to make the throttle of the car, the accelerator of the car, give you enough forward force so that it could cancel those two forces and keep yourself at 40 or 50 or 60 miles an hour, whatever you were doing. Okay? So a couple more and we'll be out. Force to the left equals 10 newtons. We got this. -10 newtons over here. Force to the right is a mystery. That's x. 5 kilograms here, -1 meter per second. They didn't even have to tell me. I read it right out loud because I saw the left. To me, that always means minus. It works its way right into the math. -10 newtons plus x equals 5 kgs times -1 meter per second squared. And that means -10 newtons plus x equals -5 newtons. Do the math. X equals +5 newtons. That's right. The winner was on the left because the acceleration was to the left. And last one. Oh, here's an interesting one. We've got more than 2 forces happening. Like I said, if you can tackle 2 forces, you can tackle any number. I'll show you how. Pencil in what you know. -100 newtons goes over here. 20 newtons goes over here. And then mystery force. Well, if it's a mystery, it really doesn't matter where I put it, does it? So I'll put it to the right. And they give me the rest of the info. Again, it's important that you recognize what the direction of the acceleration is. It's minus. Okay? So I'll pencil all my stuff in. So -100 newtons plus 20 newtons plus x equals 100 kgs times -2 meters per second squared. Work it all out. I can collapse these down and give myself a little more space to write. This is -80 newtons plus x. And if I multiply these two guys over here, I get negative 200 newtons. And add negative 80 to both sides, or add positive 80 rather to both sides, and I'll get x equals negative 120 newtons. So what does that mean? Oh, it means that the force that was unknown was actually on this side, and it was actually equal to 120. Oh, it wasn't so hard, right? Anyway, that's how you do it. So if you're consistent and you draw your diagrams, shouldn't be a big deal for you. Bring your questions to class. Take care. Have a great day, and we'll see you soon. Bye-bye.